Hello everyone. Today I will introduce force closure. The definition is the composite of wedge cone contains the entire wedge space. That is force closure. Let's recap form closure. Form closure is achieved of a set of constraints prevent the motion of the objective. So, similarly, we can understand force closure. This is the objective, and there are three wedge cones. For any actional wedge, no matter what direction and magnitude is, the composite of these three wedge cones can balance such an actional wedge. We call it force closure. In this lecture, what we discussed about friction contents. So, if the friction coefficient U equals 0, then what we apply is a normal force. Force closure becomes the first formal closure as we learned before. Next, we will discuss momentary method to deal with force closure. Keep in mind, force closure is achieved if there is no consistent moment. Let's take this triangle object as an example. There are two wedge cones. First, let's deal with the left wedge cone. It has two wedge edges. And let's see, because the force points to the right, for this wedge edge, this is positive, and this is positive, and here is negative moment. And for this wedge, this part is negative, and this part is positive. Finally, we can see this part has consistent positive moment, and this part has consistent negative moment. Maybe it's not very clear. Let's see. Okay, yes. Positive and negative. Similarly, we can deal with the right wedge cone. For this wedge cone, because force points to the left part, so this part has consistent positive wedge moment, and this part has negative moment. And combine these two wedge cones, we will see positive, where is positive and where is negative moment. Let's see. This is positive, and this part has positive. So this part has consistent positive moment, and this is negative. Here is negative. Okay. This part has consistent negative moment. For this case, we can see there is two areas has consistent moment, so it's not force closure. Think about it. Of actional force, give a positive moment in this area. The composite of these two wedge cones cannot balance such an actional moment, because the composite of these two wedge cones always has a positive positive moment in this area. Here is another example. These two wedge cones can see each other. Similarly, let's first deal with the left wedge cone. It's a similar case. This is positive moment, and this is negative. And for the right wedge cone, because the force points to this direction, so this is negative, this is positive. And the composite of these two wedge cones, let's see, positive, positive, negative, and this positive, negative. So there is no consistent moment.